Hello there and welcome to another presentation on solving systems of simultaneous linear equations. In this presentation I'm going to use a system of two equations and two unknowns to show you about three different approaches to handle these systems. My name is Charles Wasfani Msipa. So let's start this way. In general, we can be given a system of two equations. In this way, it's a11x plus a12y plus b1 equals to b1, which is the first equation, and a21x plus a22y plus b2, the second equation. So we can first number equations like that, equations 1, equation 2. So in this approach, what we do is, we basically, in the next step, after writing our equation, we can retain the first equation, there is equation 1, and then obtain a new equation by eliminating one variable there. Like in this case, I've eliminated x by multiplying equation 1 by a12. Now I take this coefficient and multiply there, and then multiply the equation 2 by minus a11. What I'm trying to do, I'm going to have the coefficients here equal and differing only by the sign, so I can get 0 here. Then after that, then I've got y with this coefficient equals to the right hand side of this form by multiplying again by the same coefficients there. So once we've done this here, I think everybody can see that we're exactly at our very first equation, which is 2 times dash equals to 8, which we said once we are used to algebra, we can manipulate algebraic expressions. We can write this as 2x equals to 8, which we solve by dividing both sides by 2 to get x equals to 4. So if we solve this equation in this way, then since this is a system of simultaneous linear equations, the y we get here should satisfy both equations. So what we'll do, we'll take that value of y and substitute it in equation 1. Y will be already a known value. Then we'll create another equation of exactly of this form in terms of x. Then we solve for x. So this is just giving you a kind of a roadmap of what you are supposed to do. But let's look at an example, particular example of this nature. Let's say we're given an equation here, 2x plus 5y equals to 16, 3x plus 4y equals to 17. So what we do, we've got our equations there, we number them equation 1, equation 2. Now we want to obtain a new equation 2 after eliminating x, which we can do by multiplying equation 2 by minus 2 and multiplying equation 1 by 3. What you can get here, you can see that we're going to get minus 6 there and the 6 there. So if we add the 2, then we're going to get 0 here. Then we've got this equation exactly of that form. Then from there, what we can now do is to say, take the equation 7x, sorry, not 7x1, 7y, what we can do now, we can grab our equation 7y equals to 14, which then we solve to get, dividing both sides by 7 to get y is equals to 2. Then what we do now, we'll now say substituting in equation 1, so substituting 1 would take 2x plus 5y equals to 16, given that y is equals to 2. That would be 2x plus 5 by 2 equals to 16, which will give us 2x plus 10 equals to 16. Then subtracting on both sides the 10 here, you will see that you get 2x equals to 6, which can now lead us to saying therefore x is equals to 3 by dividing both sides by 2. Now, then that equation will be solved. Then we'll now just write our final result here as x equals to 3 and the y equals to 2. That's the solution for that system of equations. So then let's look at the next system which were given. We've seen the system before, I think, with here x equals to 1 and the y equals to 3. So what we can do now, doing exactly the same thing. Unfortunately, here the coefficients are the same. Now we just need to multiply one equation by minus 1. In this case, we multiply the first equation by minus 1. Then we add, then we get here 4 minus 3, which will give us 1. And there we get 0. Then you get y equals to 3. Then similarly, we can now say substituting in equation 1, we get our 2x plus 3y equals to 11, given that y is equals to 3, which that's going to give us 2x plus 3 by 3 equals to 11. And then what we have here is 2x plus 9 equals to 11. Adding on both sides minus 9, we get here 2x equals to 2, which tells us that therefore x is equals to 1. And as you can see, we get exactly the same solution there. Then you can write our final solution there. Now, another approach which is slightly different but similar to this one in terms of working is the following. Let's say we're given a system of equation there. Then what we do, we take this system of equation to its matricial form. Notice that here we've got a system of equations, plural equations. And here we've got one matricial equation. And then we take it to this form. So you remember, we know that by multiplying these two matrices, this column matrix and this square matrix, we get back to that. So let's see what will be our next step. After that, what we do here in step number 1, we totally ignore the unknowns here and then create a new matrix using the independent terms here 11 and 14, and you get what we call an augmented matrix. This will be an augmented matrix. Then after that, we name these rows row 1 and row 2. So now our process of solving this system of equation will just be manipulating these rows and basically transforming this matrix into equivalent matrix, which will lead us to determining the solution. Then this is what we do in the next step. What we do now, at this point here, like we saw before, we target to have a 0 there, which you can have by simply taking separating row 1 from row 2. Row 2 minus row 1 will give us 0, and then 4 minus 3 will give us 1, and 14 minus 11 will give us 3. And then moving forward, we will see that we can now, from this step, we can go back to this kind of equation by writing it this way. And then once we've written this way, you will see that we get an equation 2x plus 3y equals to 11. And then we're going to have here 0x plus y equals to 3. So at this stage, you can see now what we have now. We've got the previous kind of form of the equation which we had. Then we can continue and do exactly the same thing. Substitute this 3 in the first equation and then determine the value of x, which you can determine as equal to 1. So you can see that this is a slightly different approach. You get a system of equations, change it to matricial form, then create an augmented matrix, then make sure that the coefficient below principal diagonal is 0. Then what you do then, you get to form where you can tell what is one of your variables. A similar process would happen if we've got an equation of 3 by 3. Now 3 unknowns, 3 equations, and 3 unknowns. Now moving forward, we can also look at this one. Up to this point here, you can see what we did is we made the coefficient below the principal diagonal 0. But what we can decide to do is we can decide to change direction and also try to achieve a 0 at this point, which we'll do as follows. So now moving in that direction now is to targeting to get a 0 there. We choose here to get a new row 1, which we can get by simply saying this this 0 here, you can simply get it by multiplying the second row by 3 and then subtracting row 1. Then you get a 0 there. Then if you multiply this one by 3, you multiply here by 3, you get 9 minus 11, you get minus 2. Then at that stage now you see that we got minus 2 there, minus that. Then you can move forward and do the following. Now what we did here, remember there's a 3 there. What we now do here, we want to achieve a 1 here by multiplying the first row, which is this one, by minus half, which will, when you multiply here 2 by minus half, we get 1, and then 0 by minus half, 0, then minus 2 by minus half, we get a 1 again. Then what we have now here is something similar to what we saw before. What we can do now, going back to this form of equation, we can see that we've got 1, 0, 0, 1 multiplied by this column vector of unknowns, which is xy equals to 1, 3. So if you carry out our multiplication here, you can see that this is going to be x plus 0y, which is simply going to give us x, and in the next row is going to be 0x plus y, which is going to give us y, and then this will be equals to 1, 3. Then once we've got that, using the equality of matrices or equality of vectors, then we would conclude that therefore x is equals to 1 and y is equals to 3. I hope you see the whole process here. Let's summarize a bit. You take the equation from this form to matrix form, you eliminate, you make sure that the coefficients below the principal diagonals are all 0. Then once you've done that, you change direction, go upwards. You now want the entries above principal diagonal. That's why now we're pointing up here. So above there to be all 0. Then you change that. Then after that, once you've got this, now what you can do now, you can try to find out factors with which you can multiply so that the entries on the main diagonal here are all equals to 1, which in this case we use minus 1 over 2 because we did minus 2 here. Then we change that. Then this is basically the identity matrix. You multiply that identity matrix with this column vector, you get the same column vector. Then from there, you can conclude what is your solution x and y. And then moving forward, we can look at this thing in a slightly different way at this point. When we get here, we can see that what we have got here, the identity, in this case what we saw before, if we multiply it by the column vector x, that will give us our right hand side, which is 1, 1, 3. But still speaking, we know that this identity matrix is the same thing to be the coefficient matrix inverse multiplied by the coefficient matrix multiplied by x, then equals to the right hand side, which you can just denote by b. So we could get this by just finding the inverse, and that is basically suggesting to us that maybe using this kind of row manipulation, we can also get to determine the inverse of a matrix. That will be our next presentation, which we're going to look at how to determine an inverse using row manipulation. At this stage, I hope the explanation has been very clear to get you to a point where you can get started with your practice. Thank you for listening and enjoy your practice.